In this video, I give a simple proof that explains why any covariance matrix is positive semi-definite. So, consider a random vector x, which is an n-dimensional vector from a sample space to n-dimensional space, with its density being rho x. Then, the mean of this random vector is given by this equation, so x times the density function and integrating over the entire space. And the covariance matrix or variance covariance matrix sigma is given by this. So x minus the mean and x minus the mean transpose. So it's a column vector, row vector. So this becomes an n by n matrix times the density function and integrating over the entire space. What we mean by positive semi-definite is this. Here's the definition of a positive semi-definite matrix. So let A be a square matrix of order n. We consider only real matrices. And A is said to be positive semi-definite if this condition holds. That is, for any vector x, x transpose times A times x is always non-negative. So this x transpose is a row vector and this x is a column vector. So this whole thing becomes a scalar. So it's just a number. It's a real number. So if this holds for any vector x, then the matrix is said to be positive semi-definite. So we are claiming that any covariance matrix satisfies this condition. For any univariate distribution, the variance is always non-negative. So this positive semi-definiteness corresponds to that fact in the case of multivariate distribution. Now, let's move on to the proof. We are claiming any covariance matrix sigma is positive semi-definite. So to prove that, let V be any vector and calculate this quantity, V transpose sigma NV. So we replace the sigma with its definition here. So we have this V transpose times this V. Now this V is just a constant vector, so we can put into the integral. So we have this here, V transpose here and V here. Now this part is a vector transposed times a vector, so it's a scalar. This one also, V transpose times x minus mu, it's a scalar. Now we rewrite this part like this. So this entire thing is put under a transpose, but we are swapping the order. Now x minus mu transpose times V. Now we have the same quantity here and here, but we call that vector transpose times a vector is just a scalar. So this is just a number, and this is just a number. So we have the same number twice. So it's this thing squared. So x minus mu transpose times V squared. But this is just a real number. So real number squared is always non-negative, and the density function is always non-negative. Therefore, if we integrate this quantity over the entire space, it is still non-negative. That means for any vector V, this quantity is always non-negative. Therefore, the matrix sigma, the covariance matrix, is positive semi-definite. That's all. Very simple. And we are done. Thanks for watching. If you liked this video, please hit the like button and subscribe to this channel. See you later. Bye.